All right, welcome everyone. Today we're going to be talking about validators and serializers. In today's lecture, during part one, we'll be talking about what are validators, how we can utilize the built-in validators inside of Django, what model.fullClean is, what that method does. We have our creating of our own validator, and then we have the Django test cases that we'll be covering during part one, where we'll go ahead and build actual test cases within Django. In part two, we'll start talking about serializes, what and why. We'll start talking about utilizing the built-in Django core serializer method along with JSON.loads. And after seeing how complicated that can get, we're going to dive into an easier tool that was created for us through Django REST frameworks. We'll talk about what is Django REST frameworks. We'll install Django REST frameworks, and then we'll utilize Django REST frameworks serializer classes. From there, we'll utilize those serializer classes to actually serialize our data from our models, and we'll utilize those serializer classes to be able to create a model entry. Does anyone have any questions over what we'll be learning today? Perfect. If no one has any questions, then let's go ahead and dive straight in. So just real quick, as of yesterday, this is where we left off. We were able to create a Django project named Pokédex project that has a Pokemon app with some fixtures inside of it, holding some JSON data. Inside of this project, we have our model, which looks as such, where we have a name, level, date encountered, and captured. When we take a look at SQL as to how that is being interpreted within our actual PostgreSQL database, here we have the columns and the types, whether they are nullable or blank. As of right now, they all show us big integer, name, which is a character varying from 100. So here we see max length is 100. And we see that we have level being interpreted as an integer, just like we said, integer field. It's not giving us the default values, which is okay. And then it's showing us date captured, which is a timestamp, it looks like. And then we have captured, which is a Boolean variable there. So our entire table was able to be introduced into our PostgreSQL database. Well, how's that happening? Can anybody tell me where is the relationship where I'm connecting this Pokédex project to my actual PostgreSQL database?
In what file?
Yes.
Settings?
Right. So in settings.py, if I come over to my Pokédex project and I take a look at settings.py, I can scroll down to the database portion. Now here in database, we can see that we have an engine that is attached to PostgreSQL and the name that is attached to Pokédex.db. Now, just like when we created our Flask server, so if we come back here and take a look at our Flask server, we had to actually tell this Flask application how to be able to find our database. And we did that through SQL Alchemy and utilizing PostgreSQL with CycloPG, all right? Well, in this case, there's a lot of assumed values that are actually happening inside of this database dictionary that we're working with here. There's actually a host key that can be utilized. And in this case, the assumed value would be localhost. There's a port entry that can be utilized, which in this case, or assumed value would be 5432. And then finally, there is a user that can be utilized, which in this case, the assumed value would be whoever is running or executing the project. So Francisco Avila, and then a password, which its default value is of blank, meaning there is no password, right? So there's a couple of assumed values that are happening within this dictionary. This isn't some sort of magical thing that's just going to assume that PostgreSQL exists within some sort of environment. There's actual keys that you have to specify with value pairs as to how to find this PostgreSQL database. Now, why is this useful? Well, as of right now, we're doing everything within our local development environment. But as we move forward, your database may be hosted in AWS, and you may have to actually place a separate server name there. You might not actually be running your database inside of port 5432. You might be running in a separate port to add an extra layer of security for your database. And the user may not be yourself. It could be somebody else that's only handling the deployment database, and only their credentials can be placed in here to be able to interact with the database that's currently on deployment. So just a couple of key things to remember there. All right, so we were able to attach just like in the database URI, and we were able to create a model just like we did back in Flask. We did it now utilizing Django. Awesome. Well, what we're going to be learning today is, if we remember back in Flask, a student object, when being pulled out of the database, was represented as a class object. And it wasn't something that was JSON serializable that could be sent over HTTP. So today we'll be focusing on creating an actual serializer that will turn this class object into a dictionary of readable data that can be sent over HTTP. And we're also going to dive a little bit deeper into the student model as far as adding constraints. Now, we've already learned constraints, such as not null, a validation for check. I'm aware that you guys also did a little bit of regex within our database SQL or SQL schemas. Well, now we're going to go into how to add constraints utilizing Django. Let's dive into it. So steps for creating a model. We want to create a model, which is the very basic outlook. Then we want to validate those fields, all right? When I'm validating the fields of each independent model, that's where I'm adding specific measurements, specific conditions, saying, hey, this is how data is going to be inputted into the database, or how I want to even create my information. Now, the make migrations portion isn't that of putting the actual chair together, like we're seeing here. The way that I think about make migrations is more of telling the arms, all right, programming these two arms that are building this chair exactly how they're going to go about building this chair. So that's just making our migration, and migrate is the actual building of the chair. And then finally, we want to test the model. We want to make sure that that model is actually usable, that it won't break depending on the dependent data, and that it's capturing data as desired. So we've gone over how to create a model at this point, but there are some basic questions we should ask ourselves before creating a model. What is this model representing? How will it look in my database? And what fields does this model need to work the way I intended to? Can I get somebody to read this slide, please?
Validators is a topic we haven't fully touched yet, but it is important we understand why and how to do this. Fields are great and most have some built-in data validations, but we need to have very specific control over what kind of data goes into our database. Validators are a way of specifying what format, length, max and min value, and even data type is acceptable for individual fields.
All right, awesome. Does anyone have any questions up to this point? Now, the make migrations and migrate portion. So at this stage, we're grabbing all of the new existing fields and validators we've implemented onto a model, into a migrations file, getting it ready to be integrated with our database and existing data. In the migrate portion, we grab the latest unapplied migrations, which is a Python file, and use it to tell CyclePG how to integrate our changes onto a PostgreSQL database, therefore actually creating our data table from our Django model. All right. And when we're talking about migrations, again, we can come over to our project structure. We can see that our migrations, we have our initial migration. I know this is the initial migration for this model because I have the variable of initial equals true there. Go ahead and open up this file a little bit. As I scroll down, I can see the fields that were created. And if I continue to take a look at my migrations file, well, there's 002, no longer an initial. Instead, it has a dependency list. Well, I'm sure we discussed this yesterday. This is a very clear example of what a linked list looks like, where every new entry is attached to a previous entry of the database, all the way up to 005. So all of the dependencies, essentially this dependency cannot exist or this initial migration of 005 cannot exist if 002 or any of the prior migrations are removed from this file, or excuse me, from this directory, all attached to the one coming before. All right, go ahead, Dan.
For all those migrations, will we wind up making a new file at the end of it as like a final rendition of it, so that way we don't have all of those renditions like clouding our final product?
So you're saying regarding migrations, as your database is changing, at some point, once you're done with development, this is solidified, what I want it to look like. Do I get rid of my migrations folder, reinitialize my migration so that I just have one very specific migration and only that one file during deployment, and you're not clouding it with a tremendous amount of files inside of that migrations folder? Is that your question?
Yes,
All right. So to answer your question, I think if you, and I think this is more of a decision base that you can make as a developer on your own. If it's something that's being pushed into production, you will, I'll say that standard would be that you will not touch that migrations file. Now, the reason why, when we work in SQL, what we have when interacting with the database as a database engineer would be all of your SQL files, right? Or considered records or reports, which is what you're turning in to actually get pushed against the database on the cloud. Well, when you're interacting with the database as a backend engineer, you don't have SQL files. Instead, what you have is those migration files. And every single one of those migration files is a record of something that was done to interact with the database and to change it in the database. So it's important to keep that living record, especially once we're talking within deployment. Now, let's say I get assigned a feature. Hey, I want you to create this feature. And in order to do so, I have to do a couple of things as far as creating a model or maybe interacting with already a pre-existing model. And I have to do a little bit of trial and error to figure out what works. Okay, well, in that case, when I pull it down to my local development, I keep track of the last migration file. I experiment, do the changes that I need to do. Okay, this is what I want to happen. I added 5 different migration files inside of that migrations folder that aren't necessary. I could delete those, make my new migration. So now there's the new entry for the feature that I needed to build, and then push that up for approval and development process or in the deployment process. Does that answer your question, Dan? Of
it does. Thank you.
course. Carlos?
So you said, so like you said, you created the 5 migration files, and then you got to your final product for that feature. So if you remove those 5 unnecessary migrations, you do a make migration. Will the make migration depend, like, will it break it? Because it's not like that 5th migration file that you created is not there. So it's no longer, is it no longer looking for those and it's just looking for the last migration file that it has? Or to keep track of like which one was the last one. I don't know if that makes sense.
Yeah, that definitely makes sense. So when you utilize the make migrations command, what it does is it goes to the migrations directory and it starts from the initial files and begins to generate almost like a replica of what the Pokemon model looks like, right? So it starts from initial and it works all the way down into 005. So now from there, it has a mock of its own representation of what the Pokemon model should look like, all right? And then from there, it kind of runs a comparison. Hey, are these two the same? Or are there any changes? If there are any changes, when you run that make migrations command, it will actually generate 006, right? Now, if I go and make changes and I'm all the way up to 10 at this point, I'm at 10 migration files, but I've realized that the last 5 entries have been unnecessary. I can keep the same exact code that's inside of my models.py, delete these 5 migration files, and then when I run make migrations, it will create 006 because the last known file is 005 when I run that make migrations command. And it will hold all of the information that is different between the last migration at 005 and the current state of my model in my editor. Does that answer your question, Carlos?
It does, but that kind of raises another one. So you can basically So it's okay if you remove from the end of the list of that migration file, but let's say you remove, like for the example that you have there, so 1 through 5, if you were to remove just 3 and you try and do make migration, since 4 depends on 3, will that cause a break?
It would. It would break it.
Okay. Okay. So only from the very end, that's the only time you can really take from.
That's
Not anywhere. Okay. Gotcha. Thank you.
of course.
So each migration file is just a diff file, essentially?
If we're comparing it to GitHub, yes.
Yes. Okay.
All right. Let's go ahead and keep pushing forward here. All right, now test. Why do we want to actually write tests? So tests won't fail if you don't write any tests, right? So now when you make tests, we're actually helping the company save money. It helps us identify errors faster. It helps us ensure the new features that we build aren't breaking anything that has already been built. And then that way developers can actually have the comfort of speed, right? I make something new, I run my entire test suite. Hey, nothing broke for as far as my new interactions. And I can continue moving forward. Now, ensure product quality by having a set standard through test, and then facilitates refactoring and adding new features. Tests are pretty straightforward. We've been doing tests since the beginning of this cohort. So I'm sure at this point, everybody's used to test-driven development, especially when you're working within frameworks such as React and Django. So now for testing the model, once we've successfully migrated our model, we want to ensure all of its fields, validators, and methods are working correctly with proper input and breaking when receiving improper input. We'll go ahead and do that today at the end of the class. All right. Any last questions before we move into seeing some code? Perfect. Doesn't look like we have any questions. So let's start applying some of these constraints. Oh, go ahead, Andy.
Sorry, I was having a hard time finding the button. My question was related to the serializer. I brought it up yesterday with Adam, but I realized that I forgot that it was also used in SQL Alchemy. Could you like give a brief rundown of the importance of it?
Yeah, the importance of a serializer?
Yes.
Absolutely. When it comes to serializers, could you bring this question back up during part 2? I'll actually annotate it myself here on my notes. And then once I get to the serializers portion, I'll go ahead and emphasize its importance and why we're utilizing it. Of
Okay, thank you.
course. All right. Let me go ahead and collapse some of this information so we don't have too much noise on the screen. Perfect. Now, we've talked about constraints, how they worked, and we see them within SQL. Well, now I want to talk about constraints within Django. How's that going to work? Right, well, there's already a little bit of constraints that I can add here. So for example, I'm saying, hey, the max length of this character field is of 100. Great. But what about minimum length? Right? Or maybe even a format in which names can be entered into my database. If it's something representing a name, I probably want to have entries going into my database where I have a capital letter. All right, so let's go ahead and break this one down. All right, that's what we're doing here. All right, so for name, I want to make sure that there's maybe a minimum value here. I already have a max. I also want to ensure that format is important. When it comes to level, well, level is currently missing a max. What would be the max level that a Pokemon can currently achieve?
100.
Yeah, right. We would want to make sure that that's equal to 100. Whenever we have our date encountered, it looks like we have a default there. And I don't necessarily think there's any sort of validation that we want to add to date encountered to not overcomplicate things. But if you're working within some sort of application where dates are important, maybe you want to make sure that no date being entered is prior to X, Y, and Z. Right? Same thing for date captured. You want to make sure that... Oh, go ahead.
Sorry, my question was, how would you make sure that it doesn't enter after the current date? Like, is there a metric to have a current date?
Yeah, you could also have something like that where it doesn't go into anything after the current date or time zone dot now, right? Because time zone dot now is the current date. And then for captured, well, captured is pretty straightforward. It's a Boolean field, so it could either be true or false. So there's nothing there that we can actually add as some sort of validation. So let's concentrate on these first two to actually bring those in and implement them into our name and level validation here. Well, constraints, when being added inside of SQL, they're just keywords that are followed by some sort of check. Well, when I want to implement these constraints inside of Django, I want to do those utilizing information from within Django. So I'm going to go from Django.core.validators. And I'm actually going to change these to say import Django.core.validators as v. So that will give me the entire access to the validators file from v. So now v is a variable for the validators file. Well, what exactly does that mean? Let me go ahead and make this a little bigger here. I can go into the validators file here inside of Django, and I can see all of the reusable classes or different validators that I can utilize. For example, there's a regex validator that I can use. There is a domain name validator. Well, that's pretty cool. Would have been good to know that that even existed. Did not know that existed. Good for them. There's a URL validator. Notice that all of these are inheriting from the regex validator. It's all written inside of object-oriented programming, which we're familiar with. There's an email validator, which is going to be useful once we're actually creating users. And there's a couple of different ways to validate those addresses as well inside of that email validator. We have a base validator. Here we go. A max value validator. That will check if something is greater than something else. A minimum value validator. Notice these are all utilizing the decorator of deconstructible. I'm not going to open up that decorator because it's going to send us down a rabbit hole. But here we can see a couple of different validation methods that we can utilize within Django. So let's apply them. In my name, well, I want to add validators. And in the model takes in the attribute of validators. And there, inside of this list, I can add which validators it is that I want to add. So here I can say that my minimum validator or min length validator will be gonna go with 3 characters. I think that's the shortest name for a Pokemon. I'm gonna go with 2 actually, because I don't want to be surprised. All right, so minimum length available for a new Pokemon being entered will be of 2. We'll talk about format here shortly. And then for my level, well, in my level, again, I want to add the validators inside of this list. I'll say that my max value validator in this case will be 101. Because let's take a look at this validator here. So this validator ensures this value is less than or equal to. Okay, perfect. So less than or equal to. That means that I could change this to be 100. And that will allow my model to get all the way up to 100. So a pretty simple implementation of the validation process. We'll go ahead and import from django.core.validators as v. And this allows us to actually add validators into my fields there. Now it looks like there's a description field inside of our inside of our curriculum that is not being demonstrated here, and that is okay. But if we wanted to add a description, we could add a min and max validator there as well. So for example, let's go ahead and apply. I want to add a description for a Pokemon where I'll have a models.text field. where default will be set to an F string of self.name. Ooh, that doesn't exist yet. Maybe I could do name. Perfect. Is a new Pokemon. All right, so now I've added a default value. And I can add some validators where I have a min length validator because a string is evaluated by length, where I can say the minimum length will be 7 characters. And I can say the maximum length would be, let's go with 350 characters. All right, so just like that, I have a couple of new fields, or one new field named description, with some validators being implemented. My level, which now has a max value validator, and then my name, which also has a min length validator. Notice that I included a max and min for description, and that's because I'm utilizing a text field, not a char field. All right, so a text field can take, I believe, up to 500 plus characters. So by limiting it to 350, now I know that when it's actually entered and saved inside of the database, it will be so with only 350 characters. All right. Does anyone have any questions over adding or the how to add validators into each independent field? Let's hear it, Carlos.
This would be, I guess, a little bit more on the behavior of the validators. So whenever you go into the admin site and you do basically your default, or maybe not the default, the max value or in the field. So if you give it a daytime field, but HTML that shows up for that daytime field, you're going to see a little calendar and a clock and whatever right next to the field. Do you get the same kind of HTML functionality with validators?
So as far as the functionality that comes from validators is when you try to create a new entry, it's going to actually raise an error and tell you that you can't create an entry. That's as far as you'll get for validation. It's not going to give you some sort of portal where you'll be able to manually interact with the validators to change their values, or you won't be able to interact with the actual model columns themselves to change which validators are being applied. If you try to create a new entry and that entry does not meet your validation, it will reject it and tell you why it's being rejected. Does that answer your question?
Yeah, because I was thinking more for like the text field, you know, how sometimes you have like a character count, like how many you have and how many you have left kind of thing. I was wondering if maybe that would give you a little bit something in the text field, but
Yeah, so it wouldn't give you something like a character count saying that the max is 350. What would happen is you would actually write a description yourself. And if it exceeds 350, the field of text field will allow more than 350, right? But when you go to submit, the creation of that object would be rejected. And it would tell you that the text field exceeded the max value validator of 350.
thank you.
Of course. Andy?
Just a follow up to that question is when we get an error on the back end, would the user receive that same error on the front end, or are there additional steps taken on the front end?
That's completely up to you what kind of error you want to display to the user. The typical thing to do is you capture all of the different areas that failed whenever you try to create a new entry, and you send those error messages back to the front end. And then it's up to the team that's actually working in the user interface how they want to present those errors to the user.
Okay.
All right. Awesome. Well, let's go ahead and apply these, right? Because as of now, if I take a look at my model inside of SQL, there's no changes there. Well, let's go ahead and open up this here. Oh, it looks like my virtual environment was deactivated. So let me go in here and activate it really quick. All right, great. So there's my virtual environment being activated. I have everything that I need. Well, I can run Python, manage PY, make migrations. All right, so there's a new field that was added, And then there's a couple of alter fields on Pokemon level and on Pokemon name. Great. I take a look at my migrations. It tells me a new one was created, 006. Come down to it. All right, there's my migrations. Here's my new field. Here's my alter field, which we can see that there was validators being added, and it tells me where those validators are currently existing. Great. Well, now let's actually apply it to the database. So I run migrate. It tells me everything was successful and the application of 006 was successful. Nice. Well, now let's see if anything reflects inside of my data table. So my data table doesn't actually show me much of these unique checks or anything as far as, hey, what happened to all the validation process that I've just created? Well, what does that mean, right? If my PostgreSQL database isn't showing me any of those applications, but Django is tracking it, what does that mean as far as the handling of these validation? Where is it happening? Is it happening at the server level or is it happening within the database level?
Server level if it's not shown in the database.
Perfect. So all of your validations are being managed and tracked within the server. None of it is actually being reflected or applied inside of your SQL database. So that's an important thing to keep in mind whenever you're working within Django. All right. Well, we just talked about validation in as far as what has already been built in. But what if the validators that have been created for me don't necessarily match what I'm looking for? Well, what I can do is I can make my own. I can touch inside of Pokemon app a validators.py. And let's go ahead and interact with this validators.py file. Well, I'm going to make a regex parser here. And this is going to be to testify for the name that I'm going to be creating here. So when I create this validation name, I'm simply going to create a function named validate name. And this function is going to take in the new name parameter that's being inputted here. I'm just going to specify that this is a string. All right. Now, this name should be able to meet a specific regex. So the regex that I'm looking for will be as follows. Well, the string must start with an uppercase letter between characters of A through Z and should be followed by letters of characters of A through Z of one or more, and that should end the string there. Right? I'm not allowing for spaces as of now. I could change it so that there's spaces, but not in this format. All right. Well, now I want to specify, hey, is this a good match? Or does this name actually meet my regex? And I utilize an F instead of an R out of habit. Let me get rid of that. Great. So I'll say good match. And I'll make that equal to the re.match, which will return either an actual object or none. So in here, what I'm actually going to be testing will be the regex that I've created and the name that's being passed in my function. All right, let's hear it, Andy.
In this, is there a typo? You're using a star instead of a plus? Because here you would, if you would take in one, it would conflict with your validator.
Yeah, you're absolutely right. So what you're referencing to is a star is 0 or more, and a plus sign is 1 or more. Thank you. Good catch, Andy. All right. So now we have the regex. It's going to check it. If it matches what we're looking for, it will go ahead and say, if good match, well, I just simply want to return the original value of the name. But if it is not a good match, I could write this in an else statement, or I could just go straight into it. Well, I will want to raise something, right? I want to let the user and my program know that there's some sort of error. But if I utilize an exception is more of a programming error. So maybe exception isn't something that I'm looking for. Instead, what I want to specify is that I am trying to access a validation error. Well, exception is built in to Python, but a validation error isn't. That means that I have to grab my validation error from Django. So again, I'll go into Django.core.exceptions, and I'll import a validation error. So now I can raise a validation error that will take in some sort of error message. So I can say name does not match proper format of one uppercase letter followed by one or more lowercase letters. And then I can specify the parameters here where I can actually give it to my user or myself. I can say, hey, this is the name that was passed in, and this is the name value that was given into this function. And that's it, right? I create a function that will make sure the name being passed in matches a specific regex. If so, it returns the name because it was successful, and otherwise, it raises a validation error. But now let's use it within the models. I can say from .validators, that's from this module, Pokemon app, validators, which is validators.py. I want to import validate name. Again, this is a different validators file than the one we're referencing in line 3. In line 3, we're talking about in Django, there is a module named core. So just a directory named core that has a file named validators. And that's where we're grabbing this V from. In the one below, we're saying from this module, so from Pokemon app, there's a file named validators where I'm grabbing the validate name function. Great. Now let's apply it. I'm going to go to my name and add my validate name function. Fantastic. Let's go ahead and make sure that this works by running some migrations. So Python manage py, make migrations, and then Python manage py migrate. All right. Everything has been entered into my actual Django project. My validators have been created. And this might raise a question, right? Well, hey, we have all of these validators now. But if I take a look at my fixtures, in my fixtures, most of them don't follow the information that I want, right? For example, Pikachu, that's not in the correct name format. Charmander is in the correct name format. And all of these already exist within my database as well. So how do I manage this information? Well, let's see what happens when I try to load data again. Let's go ahead and run Python, manage py, load data. We're doing this from Pokemon app, fixtures, Pokemon data. Wait, my fixture files are being installed perfectly fine. So are they not interacting with any of my validators? So if I'm loading data from the fixtures, it doesn't actually interact with my validation. Well, what happens if I try to create one? Let's go Python manage py and go into, oh man, what is again?
Shell?
There you go. Thank you. Shell. Right? And I enter my shell. All right. Subgen objects automatically imported. Okay, what object were those? Cool. Anyway, let's go ahead and go from Pokemon app dot models. I want to import Pokemon. All right, so that was successful and I have my Pokemon. And it looks like the two fields that I need are name and level. Well, let's go ahead and create a new entry. So let's say new Pokemon is equal to Pokemon dot objects dot create, where we'll pass in name to be Blastoise. Let me actually create it this way. And we'll pass in level to be 103. All right, so there's the two fields that I need. Everything else has default values. All right, let's make sure that's true. Here's my field for name. All right, there's not a unique, oh, there is a unique key, great. Here we have my field for level, which doesn't have a default as well. We have our dates encountered, which has a default. Same thing for my time zone. Captured has a default. My description has a default. So that should be everything that I need to actually create a new entry. Why run this? This doesn't seem to actually raise any sort of error. Well, why could that be? Well, in order for Django to explicitly run my validation logic, I actually have to utilize a method called full clean. Let's apply it inside of this shell here. I'm going to go ahead and say new Pokemon dot full clean. And just so that we're all tracking, if I run select all from my Pokemon database there, you can see that Blastoise, when I utilize that create, has also been added. But did I already have Blastoise? Let me see here. Yeah. All right, so Blastoise is in there, which is a problem altogether. If I run .full clean, well, you'll see that when I utilize full clean, it actually raised some validation errors. All right, followed by one or more lowercase letters. Here we go. So we're getting both my name, which didn't match, and we're getting both the level, which didn't match. All right. Well, if that's the case, why did it even create one? This goes into the whole process of how Django is actually running code in the background. So let's go ahead and go into how we would properly do this. All right. So now I'm going to create Blastoise. But instead of creating Blastoise, utilizing objects.create, actually, here, we'll go new Pokemon dot delete. All right. And now if I go in SQL and I run my select query, Eevee's still there, but currently we no longer have Blastoise showing up. Fantastic. All right. So now I'm going to go ahead and create Blastoise. But instead of utilizing this objects.create, I'm going to utilize it by just calling Pokemon. Okay, so new Pokemon now exists. If I type in new Pokemon, you'll see I get a return value. Well, now in SQL, if I run my select query, a new Pokemon wasn't created this time. All right, so important thing to annotate there, right? When I go into creating a new Pokemon, I should do it by calling the model itself, followed by arguments. Then I should utilize the full clean method, saying model dot full clean. So now I can run new Pokemon dot full clean. And you'll see that this gives me validation errors. it tells me, hey, there's actually errors here that run with validation. This does not match the proper format. All right, let's change it. Let's say new Pokemon dot name is equal to Blastoise. We'll go ahead and change new Pokemon dot level to be equal to 10. And now we'll run the full clean method. It looks like the full clean method is still giving me an error for my name here, but no longer for my min value validator. So let me go ahead and run that one more time. Let's see what the Pokemon.name is. Oh, excuse me, new Pokemon.name. So it has it as Blastoise, but I'm not liking that quotation marks on the outside. I want to make sure that I read it properly. Okay, so it is reading it properly. It's a problem with my regex, it looks like. So let's quickly fix that regex. I'm pretty sure the issue is this plus sign, I would say would be the issue.
Is it that dollar sign in front of the capitalization?
It
Shouldn't
is.
it be a caret?
Yep. Thank you so much. Let me go ahead and exit this because unfortunately that is going to break everything. Let's go back into the shell. Let's go from Pokemon app dot models, import Pokemon. And now let's go ahead and create our new Pokemon, which is going to be of name. Let's do this simpler. Let's go with Blastoise.
I think you have them reversed, the dollar sign and the caret.
Oh, yeah, I do, which is the start and the end. Thank you. Was that what you were trying to tell me, Carlos?
That's it.
All right, let me go ahead and exit one last time. Look at that. That's what I get for being rusty on regex. All right, so from Pokemon app dot models, import Pokemon. Let's say new Pokemon is equal to Pokemon Blastoise 22. And now we can do new Pokemon dot full clean. All right, Blastoise is still value must be an integer. Oh, it got them mixed up. Perfect. Interesting. So there we have our name, which is Blastoise, and then we have our level, which is 10. There you go. So now we have no errors coming back from our Pokemon because we have finally created our Pokemon correctly, which follows our actual regex pattern and is able to take in the proper input. All right, so now full clean method works. Well, because the full clean method works, we can go ahead and return this Pokemon, or actually save it. So now I can say new Pokemon dot save. Well, if I dive into SQL now, and I run select all, you'll see that Blastoise has actually been entered into my database. Awesome. Well, now I validated. I've been able to validate. I did everything with Pokemon data, and I went into a shell to kind of test my code. But even just right now, when I went into the shell to test my code, you'll notice that this took us a pretty good amount of time, just being able to make that new entry in the proper way. Well, there's got to be a better way to try to ensure that all of my validators are working properly. Well, this is where Django test cases come in. I can go into test and I can very quickly create a new class named Pokemon Test because I am testing the Pokemon model. I'm going to be implementing test case here. Now within this class, I can write my test. And the convention is that it just has to start with the word test. Well, inside of this test, this is my very first test that I'll be writing. And it will check that I can create a Pokemon instance with proper input. All right, I'll go ahead and say my new Pokemon is equal to Pokemon. And let me go ahead and import this class here. So I can say from dot models import Pokemon. All right, now this new Pokemon will have a name of Blastoise. And it will have a level of 10. All right, I'm going to try something. I'm going to try to run the full clean method. If it works, well, I'm going to self.assert is not none for my new Pokemon. Meaning that it's actually still there. It was never raising any errors. And it still exists. Well, then I'm going to catch the exception of a validation error as E. Again, I'm going to go into Django.core.exceptions. I'm going to import validation error. Well, if this happens, I can print E.message. And I can actually take a look at the entire message dictionary. And I can fail my test because this should have passed. All right. Well, let's go back into Python here. Let's exit the shell. Let's actually run this. Let's do Python manage py test. Well, I was able to find one test, and you'll see that a period is representing that it passed correctly. Well, let's go back into my validation here. For example, the regex that I had mixed up, I had messed it up because I had a $sign and a $sign in there. But when I ran it, it would have told me, hey, there's a failure. And I would have seen here very quickly that the failure came from the name formatter. All right, and when I printed that dictionary, it would have told me, hey, here's the name formatter. This is the error that's coming. So during handling the above exception, another exception occurred. Assertion error none. Interesting. Let me go into my test here. All right. Not sure why this one is happening. This self.fail. But we will get into that here shortly. All right. So we were able to see why this failed. And I knew this is proper input. So the shouldn't have failed. Well, that would have told me, hey, there's something wrong with my validation here. Here you go. Oh, that's right. A start is a caret and the ending is with a $sign. Well, now I go ahead and run my test one more time, and there you go. It passes correctly. Well, just like I tested proper input, I can also test improper input. All right, so I can go to my test here. I can say def test 02. And in this case, what I'll be testing is creating Pokemon with improper input that will inherit self. All right, and I can take this one step at a time. I can say, hey, my new Pokemon here is going to be a Pokemon where The name is, let's just go ahead and put some numbers in there. The level is set to 103. And let's ensure that a description is also set to XYZ, because we know the minimum is 7 characters, right? Well, now I'm going to go ahead and try to create this new Pokemon. So new Pokemon dot full clean. Now I know that should raise an error. So if this is successful, well, then I'll want to fail my message. And let's go ahead and accept our validation error here as E. Let's print the e.messageDict. And then we'll go ahead and self.assert true and pass in true for now. All right, we're going to change this test here shortly. All right, so now I run python.test. Well, hey, that passes. And I can see in that portion where I want to go ahead and print the message dictionary, I can see that the name raised an error. I can see level raised an error. And I can see description raised an error. So I can make a for loop here. I can say, well, now I want to for key in e.messageDict. And I can have something like fields that failed be equal to name, level, and description. And here I can say if key not in fields that failed, like in self.fail. And otherwise, then it passes, right? Because I know the name, level, and description of this Pokemon should have failed. So I can go through and check all the keys in that dictionary to ensure they're all present. And if it all passes, then my test is true. I was able to catch all of the improper inputs and ensure that my validators are working. All right. I know I moved pretty fast through this, so let's do a quick recap and then we'll open it up for questions. We had our model, which we had already generated. From our model, we went ahead and applied validations coming from Django.core. We applied the min length validator, the max value validation. We also created a field for description where we added the default value in there. We went into creating our own validators utilizing regex for ensuring that a name was following the proper format. From there, we managed the order in which Django actually goes into creating or how we should manage creating a new Pokemon. So first, we followed with a model with the proper arguments. Do not utilize model.objects.create because it automatically creates an entry within the DB, whereas model args does not create the entry within the DB. We went into the full clean method, which actually runs all of my validation logic to ensure that a newly created model or a newly created instance of a model follows all of our validation logic. And then finally, we went into test cases where we created a new Pokemon with proper inputs. We utilized the full clean method. If the full clean method didn't raise an error, then we knew that this test was meant to pass. If it did raise an error, we would want to see the message dictionary. So I'm printing it out there so I can address any sort of issues. And I also want to fail the test because this should have been successful. and the fact that it wasn't means that this test is a failure. Then we tested the creation of a Pokemon with improper input, where if the full clean method did not raise an error, we would want to fail the test. And if it did raise an error, we would want to ensure that all of the keys inside of that message dictionary follow the fields that we're supposed to fail. If any of them did not exist within the fields that we're supposed to fail, we would have got a self.fail message. And then we assert true, ensuring that the actual test itself passes. All right. At this point, does anyone have any questions over how we went into creating validators, utilizing validators already used within Django, and applying test cases? Carlos.
Could you go over on line 12 there with the assert is not none? I'm having trouble following them.
Yeah, so new Pokemon currently is an instance of Pokemon. So here, I just want to make sure that the instance of Pokemon still exists. This is going to return true by default, because currently this new Pokemon.fullClean doesn't change the value. Instead, it raises an exception, which is why we're within the try and except block. Right? I could just change this to self.assert is true and place that there on line 12, and that would still function. Instead, what I want to do is I do want this to pass to the full clean method does not raise an error. If it did raise an error, then I wanted it to fail, which is why we have this try and catch block. Did that answer your
Okay,
question?
so yeah, so this assert is not none. It's basically your test is like that it didn't go into the exception portion of it.
Correct.
Okay, that makes sense. Thank you.
Dominic?
Oh yes, the for Django validators, doesn't it have a regex validator? Did you create your own just as an example, or is there a specific reason you didn't use their regex?
That's a great question. Yes, we created one ourselves just as an example, but they do have a regex validator that you can utilize. All right, any other questions? Perfect. If there aren't any other questions, let me go ahead and pause our recording here. Oh, that wasn't it. All right, welcome back, everyone. Now, we got a little bit of practical application with some validators, being able to add validators, and working with a little bit of test cases inside of our projects. Well, now we're able to have validators and information, but now let's talk about serialization, right? Well, what is the importance of serialization? Let's go ahead and take a look at TL draw here. Now, I'm sure we've seen this a couple of times now. We'll go ahead and do a client, which we know is written in JavaScript because JavaScript is the language of the web, right? Well, on the far right-hand side, we go ahead and we have our database server, which we know is written in SQL. All right, fantastic. Well, in between these two, we have this monster, which is a server. And a server's job, specifically our server, is to be able to interact, or actually, we'll say it this way, a server's job is to be able to respond to a client. All right, but our server is not written in JavaScript. Our server is written in Python. All right. Well, now, if my server's job is to be able to respond to a client, what does that mean? What is this traffic that's going to be sent back and forth be written in as far as a language, right? When I send a request and a request is received, there needs to be some sort of response. Now here we're going to go ahead and talk about HTTP request. Well, the body of that request and response should be written in what language?
JavaScript.
Okay, JavaScript.
JSON?
Yeah. So we could say JavaScript because that is the language of the web. But to keep it even simpler and lighter, all requests in HTTP are sent through JSON. All right. Well, what does that tell me? We'll go into post and update methods later on. But in this case, the example of get does not hold a body. Therefore, my request looks pretty simple or pretty empty, right? If I were to take a look at an example of a request here, it would more than likely look like this. So we're talking about axios.get from http//localhost at port 8000. And let's go ahead and do API/version1/Pokemon. All right. That's currently the request that I'm working with. That's to be able to grab all Pokemon. All right, pretty simple and straightforward so far. All right. Well, now, what does that mean inside of my server? Well, in my server, there's a couple of layers. And we are starting from the very back portion of this layer, where we have our model. And our model is a Python representation. So let's do it this way. Pythonic representation of a SQL table as a class. All right.
Are you trying to share your screen?
Am I not sharing my screen, everybody?
I see your screen.
Everybody, my drawing, is that correct?
Yes.
All right, perfect. All right, so I have a Pythonic representation of an SQL table as a class. Now, when this is queried from the database, what I'm going to receive is going to be a query object, which is just one instance. Or I can receive a query set, which is multiple instances. All right. If I were to throw PsychoPG into this monster that we're talking about here, PsychoPG would be working in here. And what we're talking about these query sets is select all from DB with a limit of 1. That would be a query object. And select all from DB would be a query set. All right. So we have a couple of ways to be able to grab this information. We haven't necessarily gone into querying the database just yet. But we have seen a couple of examples where my data is coming over from Django and being represented inside of my database. All right. Well, now that I have this model here, well, I know that my response should come back as a JSON body. We're not going into the view portion just yet, but what we're going to do now is we are going to add a layer called the serializers. And the serializers are in charge of transforming model, transforming model query objects and or query sets onto JSON readable data. And once I have my model represented as a query set, well, then I can return something that would be a list of objects, where each object would be representing a Pokemon, right? And we can see a really good example of this in the Poke API. If we come over to the Poke API and I just go to Pokemon, well, what I get is a body and this results list here that is being represented to us. This isn't some sort of Pythonic language that's being represented there. No. Instead, there is a view that's responding where it's grabbing all Pokemon by saying, hey, I want Pokemon.objects.get, and it's saying limit 20. I know you guys can't see this just yet. You will see it here shortly.
I can see it.
Oh, you guys can see it already? Perfect. It will then grab the Pokemon and serialize them. And then it will return that into results. Let's see if I can do something. There you go. All right, so we can see an example here. We have Pokemon that are being grabbed with a limit of 20. Those Pokemon are then being serialized because they're originally just query sets coming back from the database. So before they could be entered into this results list, we have to serialize them and then return that serialized list. And that's how we can make our information from a database readable for HTTP to be able to send database entries or just representations of our data entries over HTTP as JSON. That's the importance behind serializers. I believe that was a question earlier from Andy. Did that answer your question, Andy?
Yes, thank you.
Of course. All right. So now that we know the importance and the why of serializers, let's go into implementing our serializers ourselves. So I'm going to go ahead and utilize this playground here to write all of our code, and then I'll just go ahead and copy and paste this code into the shell so that we can utilize it. And here, I'm going to go ahead and import a Pokemon. I'm actually jumping a little, no, I'm not. All right. I'm going to grab Blastoise. And I'm going to do this by grabbing Pokemon.objects.last. I know that was the very last entry into my database, so now I can actually grab Blastoise. And I can print Blastoise if I wanted to see it. It's visual representation. So let me go ahead and go into the shell here. I'm going to paste these lines of code there. Yes. All right. When I run this, you can see Blastoise is yet to be captured. A representation of Blastoise is happening. Well, let me come over to my model here, and I'm going to actually comment out this dunder string method. All right. I'll go ahead and exit, go back into my shell, and paste it again. Well, now when I run this, I just get Pokemon object 5. Okay, great. Well, in the TL draw that I demonstrated earlier, we talked about how we would get a query object or a query set. Well, now I need to go through the process of actually serializing this Pokemon. Now, there's a Django built-in way of doing it. Inside of Django, what you can do is you can ask for Django.core.serializers. And from there, you can import the serialize method. Now, the serialize method takes in 2 arguments. The first being the format for the serialization, and the second being an iterable list of objects to serialize. So in this case, we have Blastoise. How could I apply this serialize function? I'm going to go ahead and make serialized Blastoise here. How can I apply this serialize function?
Serialize, open parentheses. Is there a JSON format?
Perfect. So we want to send it into JSON.
And then start a list, brackets, and toss in Blastoise.
Perfect. Because it is an iterable object, right? I can't just pass in Blastoise. It actually needs to be an iterable object. So let's go ahead and exit here, go back into our shell. Let me copy and paste this. I'm sure there's going to be an allow or always allow. There's not. There's a do not ask me again, so good. All right. And now we can see that Blastoise is the very last line there. Well, when I run that, let's take a look at what serialized Blastoise looks like. Well, now serialized Blastoise is actually an iterable JSON object. You can see there that we have the square brackets, which means this is iterable. It's expecting multiple objects. But you can see there that in index 0, we have the model of Pokemon where the primary key is 5. We have all the fields with their key value pairs. And it looks like I made a mistake in the description, and that's why we're seeing this Django.db.models.fields.chart field. That's okay. We're not going to stress it too far. We'll go back and correct it here shortly at the end of the class. All right. But this isn't necessarily something that I can work with, right? If I wanted to work with this Pythonically, I wouldn't be able to actually go into index 0 at key PK and expect it to return the number 5. Why is that? Can anybody tell me a significance in this return statement? And I'll give everybody a hint. What's up with these parentheses at the very end? What is the actual structure that we're seeing printed into our terminal there?
A string.
Yeah, it's actually a binary string that's being returned to us. All right. So the serializer, not only does it take in those two, but what it returns is it returns a JSON representation as a binary string. All right. So now let's go ahead and add these two print statements there. We have Blastoise and we have our serialized Blastoise. Okay, it's a binary string. How do I turn a binary string into actual JSON that Python can work with?
Typecast it.
Yeah, I could typecast it. I could try to typecast it. I could try to change each individual value. I could make some sort of parser that would be able to do this. But the easiest way of working with JSON is by bringing in JSON and utilizing the method of JSON.loads. So now I can say Blastoise dictionary and make that equal to JSON.loads, pass in the serialized Blastoise, and grab index 0. And now we can print our good old Blastoise, or I guess Blastos. All right, so let's take a look at this. I'm going to go ahead and paste it. We run this. All right. So first, we see the print of Blastoise happening there. We get a Pokemon object. Then we serialize Blastoise. When we print it, we get our binary string being represented there. We utilize JSON.loads to turn that binary string into an actual list of dictionaries and grab index 0. because that's where Blastoise is located. And finally, I have an actual dictionary that shows me all of Blastoise. All right, I can go ahead and alter this and work with this so that I can change the data into something that I actually want to be represented to the user. Example of this, if we go into Poke API one more time. Well, when I query the database for 20 of them, notice that all I'm getting back is the name and the URL. But that's not all the information that I have pertaining to a Pokemon. When I go to Pokemon/1, then I get all of the information that I have pertaining to one Pokemon. So I can change this information, right? Maybe what I want to return is, I could say return dict is only a dictionary where we have PK, and we do Blastoise dictionary dot get PK, and we only have name, where what comes out from there will be Blastoise dictionary dot get. In this case, it'll be fields, which returns a dictionary. So we could do dot get again and grab name. And now when we print the return dictionary, let me go ahead and copy all of this. Let me exit to avoid having too much noise here. Enter our shell one more time, paste it all in there. All right, we run this. Well, now we can see that when I run this return dictionary, all I have is the primary key and name. So my serializer can grab from the database. It can turn that query object into JSON readable data. And then I can manipulate the fields to create my actual return dictionary. All right, that's kind of a long process for being able to serialize some information. And this is the, I guess, the original way, right? With nothing built in, no tools added. This is just a serialized method that's being provided to you, which in itself, I think is a pretty good tool. But there is kind of a couple of hoops to jump through, right? I have to, one, serialize it to Blastoise. It only works with iterable objects. So if I'm working with something individual, I always have to grab that 0 index to pull it out. And if I wanted to change the information in there, I actually have to load it back with JSON so that I can manipulate it as a dictionary. So although it's powerful and it's grabbing information, allowing me to work with it, it's not actually giving me the best functionality that it can. Right? It's still having me hop through a couple of hoops. Well, how do we fix that? Well, as we continue developing in Django, we're going to notice that there's a lot of things that have become common or common functions within Django, to the point where somebody went out of their way and said, you know what, it would be fantastic if somebody can take all these hoops that you have to jump through and instead of create a module where everything that we just did is still happening under the hood, but it gives a better interface for the regular developer to actually be able to create these functionalities. Well, that's where Django REST framework comes in. Somebody went through the process of saying, well, there's a lot of information that we all do that we need the ability to do so in a quick manner. And I'm just going to create this REST framework portion so that people can install it and grab the tools that we have created for everybody. And hopefully it makes people's life easier. And in this case, it absolutely does. We're going to be utilizing a lot of Django REST framework for the remaining of the cohort. Now, again, Django REST framework is not a magical thing. It doesn't come with code that we don't have any sort of access to. Everything that we just did, Django REST framework is actually running it under the hood. but it simplifies it for us. So here's what I mean by it simplifies it. Let's go ahead and create a new file called serializers.py inside of our Pokemon. I'm actually going to close a couple of these just so that there's not too much noise here. All right. And here, oh, well, first things first, I want to actually install my dependency of Django REST frameworks. So I'll go ahead and say pip install Django REST framework. And let me go ahead and copy that and share it with everybody here on Slack. All right, I run that, and we can see that Django REST framework has been successfully installed. All right. I'm going to go into my settings to ensure that this gets recognized. And you'll actually see all of these steps here as well. You can do pip install Django REST framework. And then from there, in installed apps, just ensure that you add REST framework as well. Now, the rest of these, such as Markdown and Django filter, those are all just suggestions. You don't necessarily need them unless you're really diving into Django REST framework, you can. You could even clone the actual project itself so that you could have something that you can work with and alter the tools within Django REST framework as well, if you would like, rather than just overriding them through polymorphism. So I'm going to go to my installed apps, and I'm going to go ahead and add REST frameworks. Okay, great. I'm going to end it with a comma. And that's it. An app didn't actually populate. I don't need to conduct any migrations, right? I can do Python manage py make migrations, and you'll see that there's nothing to be detected. Well, now in my serializers, I can actually grab from REST framework. So I'll go from REST framework dot serializers. I want to import the model serializer. Now the model serializer, this is specifically made to actually be able to conduct CRUD operations such as create, update, delete, and read for your database or all of your models that are being represented inside of the database. You can see that this inherits from the serializer class. The serializer class has a base serializer as well that I can go over and take a look at. And then at this point, this base serializer is no longer coming from REST framework. I'm pretty sure now we're actually interacting with Django itself. And we could keep going down the rabbit hole to see where all of this code comes from. But under the hood, everything that's happening from REST framework is utilizing the tools that are already provided to us by Django. They're just being summarized and provided to us in a better interface so that we can interact with them easier. Well, let's see. How can I interact with them easier? I'm going to make a class of Pokemon Serializer. And this class is going to inherit from the model serializer. Now, the model serializer takes in a couple of things here. So one, it takes in the model, or excuse me. One, it takes in a child meta class. Within that child meta class, it expects model to interact with. And then it expects the fields I would like to see. I can also add, instead of fields, I can have exclude for fields I would like to exclude. Well, let's take a look at this and how the information is returned and what the differences are. So I'll go ahead and make my class meta. where the model that I will be interacting with will be the Pokemon model. So I'll say from dot models import Pokemon. And then finally, I'll go ahead and add the fields. Where in this case, let's say the fields that I want to interact with are ID, name, and level. And that's it. Those are all the fields that I would like to interact with. All right. Well, now let's go ahead and actually run this, right? Let's put this into some application. This is just a tool, so there's not necessarily any migration that I need to do. Instead, I can go to my playground. I can still take Blastoise. So let's go ahead and uncomment some of this information. And from the serializers, I'll go ahead and import Pokemon and the Pokemon serializer. So there's my Pokemon of Blastoise. Well, now let's serialize it. I want to say serialized Blastoise is equal to the Pokemon serializer, where the information that I will be working with will be from Blastoise. And then I want to print this information here. I want to print what serialized Blastoise looks like. Let's see what this looks like inside of the shell. Well, when I go to print my serialized Blastoise, I'm getting this ID of integer, I'm getting this name and this level. So it's giving me pretty much the table in itself. And it's giving me a visual representation of what it is that I'm asking for. But that's still not something necessarily useful. Well, let's see. What if I do print serialized Blastoise dot data? Well, if I do serialized Blastoise dot data, notice that without me having to do this whole JSON dot loads, specifying what kind of format it is that I wanted to, instead, what I got was a dictionary return of the fields that I explicitly told it I wanted to see, such as ID, name, and level. And they're all hidden within the data attribute. So I can say, will return a data attribute that holds key value pairs for dictated fields. All right. Well, what if I want to see all of them? Does that mean that I have to specify each one of those fields at once? I could, but that would be a pain. So instead, I could just do underscore underscore all underscore underscore and remove it from the list. So let's go back to my playground. I know that I'm going to be taking a look at dot data here. Let me go ahead and exit. Go back into my Python shell. And let's run this. Well, now, when I include all, it's actually able to do name of Blastoise, where the level was 10, date encountered, and so on. All of the information is there and ready to go. So there's one of the benefits that comes from serializers. And probably one of the most powerful is it's able to grab an entire object and turn it into a dictionary. Now, what if I had many of them? Let's go ahead and change this a little bit to apply for many. So this is for one object. And if I wanted to see many objects, such as a query set, well, I could do like this. Pokemon is equal to Pokemon.objects.all, where serialized Pokemon is equal to the Pokemon Serializer, where it has Pokemon, and then I'm going to add a secondary argument there. Not only am I telling it, hey, this is the information they're going to go through, I'm telling it there is more than one. So you should know that many is equal to true. This allows it to work with iterable data. Whereas the serialized JSON method did not have something that I can manually change to work within data that it is iterable or isn't. The Pokemon Serializer, which comes straight from Django REST frameworks, does. Right? Well, now I can just print my serialized, because I can't spell, Pokemon.data. And if I go into run this inside of my terminal, you'll see that I now have a parental list that holds a dictionary for every single Pokemon entry inside of my database. All right, so it's a pretty cool tool for us to be able to work with. Now, this is just grabbing information from the database. But we do have a huge advantage with serializers because we can also create objects utilizing serializers, and it will not allow us to create an entry into the database unless it meets our validation standards. Now, before I dive into that second functionality, I wanted to open up for questions. Does anyone have any questions over serializers up to this point? All right.
Not a question, it's just a lot to take in right now.
Not a question, just a lot to take in. Yeah, unfortunately for Django, that's it's kind of a monster to be able to tackle it down in the amount of time that we have. All right. So now we've gone over how to work with one independent object and how to work with many objects from a query set. But now it's time to start talking about how we can go into creating an object. Well, let's do a quick refresher here. When I wanted to, let's say I want to create a new Pokemon, and let's say we're working with Mewtwo here, right? I would have to say a new Pokemon is equal to Pokemon, where the name is Mewtwo, or excuse me, Mewtwo, and where the level is equal to, let's say 70. I believe that's what, when you find Mewtwo in Fire Red, he's level 70. All right. So now let's go ahead and actually create that object. Right? Well, I would have to follow within a try and catch, where I would say new Pokemon dot full clean. If that succeeds, then I would say new Pokemon dot save. But then I would also have to have an exception. So except validation error, and have to import that. Where I can print the error.message dict. And then from there, I can try to save my Pokemon again. Well, now there's a couple of issues here, right? Or actually quite a bit of few steps that I have to go and work with. Well, one, when I create this new Pokemon, I have to be very careful with the syntax that I use. Because if I do Pokemon.objects.create, well, this method will automatically save onto my database. Right? Without even running the full clean for validation. I also have to explicitly say, hey, execute the full clean method. Now, When I utilize a Pokemon serializer, we're going to see that it's not necessarily much different. So let's just make our Mewtwo instance here. Let's say Mewtwo is equal to a dictionary where we have a name, where the value is Mewtwo, and we have a level where the value is 70. Right? I could obviously use something like object destructuring here and pass in Mewtwo, and that would still work. Great. Well, I don't necessarily like this flow. Not only that, but I'm always going to be looking at an exception being risen inside of my program. So if I have any follow-on logic, I would have to write it within the exception or write a parental function that will account for this exception. And it's not necessarily what I want. Well, instead, when I utilize a serializer, well, I can say my new Pokemon is equal to my Pokemon serializer. And I can specify with a data field that the data that I'm going to be utilizing will be the Mewtwo, which is the dictionary up above. All right, so data expects a dictionary of key value pairs matching fields. All right. Now, what I mean by fields is not the fields that are demonstrated here in the model. Instead, what I mean by fields is the ones represented here in the serializer itself. All right. Well, now, instead of running this whole try and except, I can say if new Pokemon dot is valid, which is a method that will run full clean. So if it is valid, then I'll go ahead and save my Pokemon. And I could print the new Pokemon.data. And then else, well, then I can go ahead and print new Pokemon.errors. And that will show me, instead of getting a message dict, which is showing me a dictionary of keys, it shows me in a much better format all of the errors that would happen when I create Mewtwo. So let's do it the wrong way first. And then from there, we'll take a look at what happens when we do it correctly. Oh, let's do 190. There you go. All right, I'll go ahead and save this information here. I'm going to exit, enter my shell, and paste what I have in my playground. All right. I run it. It looks like I'm getting a syntax error here from somewhere up above, likely from this pound sign here, I'm assuming. Print new Pokemon.data. So invalid syntax at print new Pokemon.errors.
I don't think you put it in the. Where are you going to put it in the error else block? My bad.
I don't need an else block. I shouldn't have a syntax error. Let's go ahead and add it in there, just in case that is the problem. And then I'm going to remove this comment just in case. All right, let me try it out one more time. Okay, great. So it looks like with the else block, it was able to tell. And here we get back a name where the error details is, hey, the string name does not match proper format. All right. And then level, where again, the error details is the ensure this value is less than or equal to 100. All right, let's see what else is there. I can take a look at error messages. Let's see what happens when I run this block of code here. Well, now when I run this block of code, error messages actually returns required. This is a field that is required. Null, this is a field that may not be null, and invalid. So it looks like this is giving me a couple of outside stuff that I can't necessarily tie. But messages gives me the information that I need. Or excuse me, errors gives me the information that I need to actually update or let a user know, hey, this is what you're doing wrong. And this is why it's not working. You need to fix this in order for us to actually be able to create a new entry in the database. Well, if I change this, and now I have Mewtwo at level 70, and I run it, and actually before I run this, we should also see that there is no new update inside of SQL. So if I run select all from Pokemon app, you'll see that the very last entry is still Blastoise. Well, now we're going to go ahead and add Mewtwo. If I go and execute this block of code here, you can see that Mewtwo is now following the correct format.
Gotta get rid of the capital T in his name to pass your regex.
Yep, that would do it. All right. Let's copy that one more time and send it. Well, now there's a new Pokemon object that has been created with the ID of 6, Mewtwo being its name, level 70, and all of my default values that I have added into it. All right. A little bit different than the original way we were making it. The main thing to highlight here is that I am no longer having to account for a raising of a validation error. And by doing it through a Pokemon Serializer, I don't run the risk of somebody creating a false entry into my database without actually utilizing the full clean method. Because a serializer will actually stop you from being able to save. So for example, if I go back to Mewtwo, and let's say I skip this entire portion, right? I just say, this is what I'm going to do. Now I want you to save. Mewtwo is no longer a correct entry. I can even make it even more wrong, right? We know both of those are supposed to fail. Well, when I run this in my database, it tells me, hey, you have an error here. It tells me you can't call save without running the isValid method first. So inside of the serializer, there's some sort of logic that says, hey, has isValid been called? If it has not been called, you cannot utilize the .save method. So it ensures that no data is actually entering your database without first ensuring that it passes all of your validators. And that's the power behind serializers. All right, does anyone have any questions over creating data entries utilizing serializers? Let's hear it, Carlos.
I know you're gonna pass the notes over at the end of the class, but could you send the serializer.py in the chat maybe, just so we can kind of so I can be able to see it side by side.
Absolutely.
I know it's pretty straightforward, but thank you.
All right, any other questions? Well, if there are no questions, let's go ahead and take a look at what the excludes fields would look like here. You can go ahead and add excludes. Again, this could take an iterable list. I can add something like description. And if I go to my playground, let me go ahead and do this Blastoise all over again. When I go to grab Blastoise, oh, I have to exit. I apologize. As an old version. All right, need this. When I go to grab Blastoise, oh man, I'm getting an error. What happened? Creating model serializer without either field, attribute, or exclude. Oh, there you go. It's exclude, not excludes. That will do it. All right, and let me paste this information. And now you can see that we have the ID, we have all the information regarding Blastoise, with the exception of description, which is what I added in that exclude method. Now, something to keep in mind, if you're utilizing exclude, you're going to run into issues when creating a new object. If you have specific fields being determined here and not utilizing all, it's going to create an issue when creating a new object. It is only going to work well when you're trying to create a new object if you are having in your serializer the underscore underscore all, or you're ensuring that this iterable list includes all of the fields within the model. So just make sure you keep that in mind when you're working within this too. All right. Now off topic, there is one portion here in my model where I messed up. So I'm just going to put this is a new Pokemon there instead and run that migration. I think this one might run me into some issues, but that is a-okay. Okay, perfect. I'm going to go ahead and dump some data. Oh, I think I remember this indent 2, and I want to dump it into Pokemon app, fixtures, Pokemon data. Nice. All right, so let's make sure our fixtures have been updated. Perfect. We have Mewtwo and Blastoise now being demonstrated there. It looks like the new default field will be represented moving forward, but not for previous entries. That is okay. And let's do a quick summary over everything that we created today. Today, we start off our lectures by talking over validators. First, we covered the built-in validators that are provided to us through Django. We then went over the process of creating our own validators and how to raise a validation error. You guys saw me interacting with the Python shell where I made a couple of mistakes and utilized our time rather inappropriately by trying to test different information, not actually being able to find what the correct error was coming from. And then we went over how much simpler my life would have been if I would have just written some tests instead. All right. We went over writing tests utilizing Django test case to ensure that we were testing for proper and improper inputs. We then moved on to serializers. We went through the process of creating a serializer on our own or utilizing the built-in method that comes in with Django for Serialize, where we were able to churn a query object into JSON readable data, utilizing Serialize and JSON.loads, and then manipulating that dictionary ourselves. We then decided, hey, this is kind of a pain. There's too many steps, too many hoops to jump through. And we went over the process of installing Django REST Framework, ensuring that Django REST Framework was added into our project settings, writing our own serializer for our model, and then again, utilizing the playground to be able to interact with different portions of our program, such as grabbing data out of the database in a already JSON serialized value, and creating new information into our database, utilizing our serializer through the isValid method. At this point, does anyone have any questions over anything we've covered today? Carlos, send it.
In the meta class for the serializer, can you, since you run into issues whenever you're trying to create a new one, if you use exclude, can you have fields and exclude? Or
No.
do you have to pick one or the other? Okay,
You have to pick one or the other. It's either fields or, of
got it. Thank you.
course. Daniel?
Is it common practice to have that playground.py in there?
No, I'm strictly doing this because I don't want to just run a bunch of things on the terminal and then inside of the shell. And then once I push the class up to GitHub, you guys don't have any of those commands. So I strictly wrote it here on the playground so that there's a living record over everything we executed on the shell.
Hey,
Of course. Any other questions? All right, if there aren't any other questions, let me go ahead and stop our recording here.